All right, so today's video is focused on Algebra 2 midterm review. So this is going to be day one of our midterm review, where I'm going to hopefully bring back some topics that we learned in quarter one and early on in quarter two that you might have forgotten about. Get us back into working on some of that material, and you guys are going to start practicing some multiple choice problems. Because a couple of things that I want to point out is that your midterm is multiple choice. And it will take place on December 15th if it's an A day and December 18th if it's a B day. Please remember that if you know that you're not going to be here one of those days, see me so that we can make arrangements in advance. Something else that I want to point out is that today the expectation is that you are going to copy down notes along with the video and answer multiple choice questions informative and on your paper. And you're going to turn this in at the end of class. So the multiple choice questions, there should be a little bit of room to show your work on the paper, but if you need a separate piece of paper, you can totally do that and attach it to it to make sure all of your work is shown. These questions are formatted very similarly to the ones on the midterm, so I would recommend that you spend some time on this. So just kind of bringing it back to what we did in Unit 1. In Unit 1, we learned about linear functions. And one of the biggest thing we learned about linear functions is that that's anything that has to do with a straight line. So the equation that we use for a linear function is y equals mx plus b. And it's important for us to know what the m and the b are. So the m represents our slope. And we also call this the rate of change. And the b represents our y-intercept. And that's kind of like our starting point. So if we were writing a linear word problem, the y-intercept could be something like an original cost or a startup cost, and then the slope would be how much it changes by each month, so how much it's increasing by. Sometimes we have to calculate the slope, so if you ever have to calculate the slope equation is y2 minus y1 over x2 minus x1. We also think about that as like rise over run. If you have a graph and you want to count it out that way, that's something that works too. So that was the first thing we learned about was linear functions. Next thing we learned about was we talked a lot about transformations. And this is something that pops up in every single chapter that we've done this year. So transformations are how our graph moves. If we're given a parent function, it's how does it move right, left, up, or down when we add different things to it. So if we have a basic function here, so for this one, I'm just using an example of a quadratic parent function because I have a squared there. But remember that these transformations can be applied to any parent function. And we're going to talk about what each of these different shifts does. So if we want to look at this k first, we'll kind of go backwards here. The k tells us how our graph is going to move up or down. So we can look at special points on the graph and move them or just talk about it in general. So if we have a plus k, it's going to move it k units up. And if we have a minus k, then it would move it k units down. Okay, so any number that's added or subtracted on the outside is going to move our function up or down. H is the one that moves our function left or right. So if we have a minus h, it's going to move our function to the right. And if we have a plus h, it's going to move our function to the left. So it kind of does the opposite of what we would think inside. So just think inside is opposite. And then the last one that we mainly focused on was A. So when A was greater than 1, so when it's a whole number or a fraction that's greater than 1, we call it a compression. And when A is less than 1, we call it a stretch. So it's another way that it can move and change our graph. So we can do that with points, we can do that on a graph, we can do that just generally talking about it, but that's a little function transformation reminder. And then the last thing that I want to refresh your memory on from Unit 1, and we've done this a little bit since then, is the idea of inequalities. Right, so when we say inequalities, we're talking less than, greater than, less than equal to, greater than equal to, all of those different things, right? So if we have a symbol like this, okay, we would say that that is less than, and that's represented by an open circle if we're looking at it on a number line. And it has a dotted line if we're looking at it on a graph. We also have greater than. And greater than has an open circle. And also a dotted line if we're going to look at it on a graph, because it doesn't have that equal to line underneath. Okay, so that means that whatever we're comparing, it can get really, really close, but can't be the same thing on both sides of the inequality sign. Next, we have less than or equal to. And this one has a closed circle and a solid line. So that means that solutions can be on the line. And that we could have the same thing. So we could say like x is less than or equal to 4, and 4 would be a true value of x. Then we have the other way. So this is greater than or equal to. And again, this would also have a closed circle and a solid line. So when you're graphing an inequality to solve it, because thankfully we have Desmos, and that's a really helpful and easy thing to do, we only want solutions that are in the shaded region or on the solid line. So I can show you an example of that here with Desmos. So if we pull up Desmos, so let's say I have an inequality. We'll say y is less than 4x plus 3. I'll see two things, right? I see a dotted line because this is a less than sign, and my solutions would be any region or any point that's in that region. So if I look at the point 2, 2, see that blue line? It's in my shaded region, so that would be considered a solution. If I look at the point, say, what's a good one? Maybe 0, 3. This point would not be a solution because it's on my line, but it's on a dotted line. So we have to be really careful about where we're looking at solutions. So at this point, If it hasn't already popped up, you are going to see the questions that are in your midterm review, those 5 questions that connect with kind of the Unit 1 stuff that we just reviewed. So go ahead and pause, take a minute to answer those 5 questions, and then we'll come back and continue our review for Unit 2. All right, so back at it again with Unit 2. In Unit 2, we mainly focused on quadratics. So when we talk about quadratics, there's multiple forms that they can be represented in. So the first form is standard form. And this is when we have y equals ax squared plus bx plus c. So this is the form that our quadratic needs to be in for us to factor it or for us to use the quadratic equation. We always want it to be in standard form, so y, which we can easily substitute for 0. The second form we have is vertex form. And just like it says in the name, vertex form makes it really easy for us to see the vertex of a parabola without graphing it. So we have y equals a times x minus h squared plus k. And the vertex, if we were just looking at an equation, the vertex is h comma k. And then the last form is our factored form. And in this one, we can really easily see the zeros or the x-intercepts. So that's when we have y equals, we'll say x minus a, and x minus b. This is where a and b are x-intercepts. Okay, so that's the main thing that we need to know about quadratics in this unit. We also looked at some real life situations and examples of a quadratic. So one kind of basic sketch we can make. So a lot of times we'll have a situation where our quadratic is looking at maybe how far and how high a football went when it was kicked by a kicker in a football game. So our picture might look something like this. And we have some points on it. And this x-axis would be considered the time. And then the y-axis would be considered the height. So how far or how tall the football went in the air, and then how long it took the ball to reach the ground. So some important points that we're often asked for would be this point right here, which that's going to be the vertex of our parabola, the turning point. But this would also be like the max height. And specifically the y coordinate would be the max height, right? Because that's how tall it was off the ground. The other point that we could look at would be this point right here, this x-intercept, which is going to be not 0 and then x, but x and 0. And this x value is going to represent the time in the air, or how long it took to hit the ground again. Okay. And then another one that we can be asked for is this point over here, where it started, and that one's going to be 0y, and that's like how high it started off the ground. So, oops, spell that right. So we'll just say starting height. and figure out what I wanted to write there. Okay. So that's our starting height. Okay, so it's kind of a reminder of even when our quadratic talks about a real world scenario, we still have some comparisons that we can make. And then the last thing that we talked about in this section was quadratic regression. So we used Desmos to answer regression questions. But the one thing we have to remember is a regression equation. So we can use this when we are given 3 points of a quadratic and asked to find the equation. And the equation would be y1, that little squiggly, ax1 squared plus bx1 plus c. So I'm going to use a little example here just to remind you of this process because it's a little bit technical. So the 3 points that we are going to use in our example is -1, 12, 2, 3, and 3, 4. This can also be used not necessarily just when it's asking for a quadratic equation, but sometimes they'll use the word quadratic model. So if you don't have Desmos open, I would take the time to open Desmos right now. It'll make it a little bit easier. So let me pull Desmos back up, delete our example from earlier. So to start off, we need to put the points that we have in a table. So I'm going to go up to this plus sign, and I'm going to hit table. And then I'm just going to type in the x and the y points I have, and I'll see them pop up on the screen. So it doesn't matter what order I type them in. Typically, I just do like least to greatest x value. But we'll see right here, I see my 3 points pop up on the screen. And so to find the regression equation that would draw a line through those 3 points, I hit a new line, and I'm going to type that equation that we wrote down, that regression equation that we wrote right over here. So I have a y, oops, typing in the wrong spot. Well, don't know where that went. I'll pull it up in a minute. I'll make Desmos full screen. So we have y underscore 1. I'm going to hit, on your keyboard, you'll look for shift and then that little squiggly line. And then ax underscore 1 squared. You want to make sure the square is on the x and not on the 1. And then plus bx underscore 1 and plus c. And then we'll see underneath the parameters pop up. So when you write the equation of the line, you would have y equals, and then you're just going to replace the a, b, and c with the numbers that you're given as those parameters. So I see that the parameter for a is 1, so I would have 1 x squared. The parameter for b is -4, so -4x. And then the parameter for c is 7, so plus 7. And you'll now see, just this is a great way to check, that my green line and purple line are mapped directly on top of each other. So this y equals x squared minus 4x plus 7 would be a model for those 3 points. So now that we've looked at some Unit 2 reminders and things, there are 3 Unit 2 review questions for you to try. After you try those, then you can move on to the next video that reviews Unit 3 and